Okay, example 18. This is a big one. It even says important, right? It's a highlight. Wow. So this is, I would say, guaranteed at least one problem on the free response will be you'll have to do something like this. So this is the idea. Well, let's get into it, and then we'll talk more as we're going. So if f prime of x equals 2x squared minus 2 and f of 0 equals 5, find f of 2 by first finding the particular solution to the differential equation. So we've already talked about that a little bit. So if I wanted to figure out, so right now I know that f prime of x equals 2x squared minus 2. Well, if I want to figure out, I need f of 2, so if I want to figure out f of 2, I've got to undo f prime to get back to f. And hopefully you could remember how to do that by doing what? So I would integrate both sides. Now you got to be picky here. You can't just randomly throw integrations in there. So we should get a little bit more technical. So this would be the integral of f prime of x dx equals the integral of the quantity 2x squared minus 2 dx. So the integral of f prime is, we're going to call it f of x. Sometimes we call it big F. I know it gets confusing when to use big F and when not to. I get confused too. All right, so then we're going to integrate this, but remember, it's a indefinite integral. So I'm going to give you a second to pause, see if you can evaluate this. Hint, indefinite integral. So you should have gotten 2x cubed over 3 minus 2x plus c. Now that's what we call a general solution if you think back to earlier in this chapter. This is a general solution because it's not defined for what c is. Now we're going to find a particular solution. Now we can find particular solutions only if they give us a hint. So they gave us a hint that f of 0 equals 5. So now I can plug in. I'm going to change the color up. F of 0 equals 2 times 0 cubed over 3 minus 2 times 0 plus c equals 5. Well, life is good. That's gone. So we get, therefore, c equals 5. So now now I can take this c value and I can put it back into our general solution to get a particular solution. So f of x is equal to 2x cubed over 3 minus 2x plus 5. This is what we call a particular solution. That's not the end of the story, though. They wanted us to evaluate what f of 2 is. So all that work was just to get us to a spot where we can now figure out that f of 2 is equal to, I'm just going to go ahead and do some of this in my head. So that's 2 cubed is 8 times 2 is 16 over 3. 2 times 2 is 4 plus 5. We got to go with some common denoms here. So I'm going to make this 12 over 3. Going to make that 15 over 3. So that's what? 12, 3 is 16, that's 19. So 19 thirds. F of 2, which is what we should be boxing in here, f of 2 is equal to 19 thirds. Part A. Okay, let's look at part B now. We're going to try to do the same thing, but we're going to do it as a definite integral. So how can I set up an integral? My first thought was to do something like this. Let's integrate from 0 until 2 of f prime of x dx. That seems simple enough to me. Problem is that's not taking into account what's happening at 0. So this would tell me how much the function has changed from 0 to 2, but it didn't tell me where I begin. So let's think about it a little differently. F of 2 equals, and I'm going to actually go down into these notes and then come back up here. So blah, 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 blah. Okay, this is where we really want to take a look at. No matter where you are at a given function, okay? For a given function, no matter what, if you start you can find out where you are based on where you started and then where you've gone from there, otherwise known as your displacement. So in our our calculus way of saying this, any moment in time of a function, wherever you are in a function, so if you want to pick a spot on a function, great. You can get to that spot by looking at where did you start, plus what have you accumulated, there's a big word there, accumulated since then. That accumulation is all those little, remember those little rectangles that we did before in the Riemann sums? Those little rectangles, as you add more and more and more of those little rectangles, you're accumulating more and more area. So tell me where you started, at what height of your function, and then tell me how many of those little rectangles you've accumulated since then, and that will tell me where I am on the actual curve. So going back up here, f of 2, well, I could start anywhere. You could start wherever you want, but they're going to give you some sort of a hint that's going to give you a good starting place. We should start at f of 0 because we know how high f of 0 is. And then from f of 0, I'm going to add on everything that I accumulate since f of 0. So I'm going to start at the height of f of 0, and then when I add up all the derivatives from 0 until 2, that will tell me what happened from 0 until I got to 2 and put those two things together. So if I were to kind of highlight some stuff here, this is the y value at x equals 2. That's what we want. The y value at x equals 2, though, can be found by looking at the y value at x equals 0, and then finding out how much or what has been accumulated since, let's say, since you started. What you've accumulated since you've started. So this is a big one. I'm telling you guys, it's going to be on the AP test. I guarantee it. It's a big one on my tests too. But for those APers, this is a big idea. So let's actually go ahead and figure this out. Now, what's nice is we know what the answer of f of 2 is. We've already done this. We know the answer should be 19/3. But let's look at how to do it using this technique. So we would say f of 2 is equal to, what's f of 0? That's 5. Plus, this is a definite integral. So what's the integral of f prime? I'm going to just integrate it over here. So that would be 2x cubed over 3 minus, minus 2x from 0 to 2, which equals 5 plus, that's going to be, I'm going to plug in the 2 now, 8 16/3 minus 4 minus 0 is 0. And I get 5 plus 16/3 minus 4, which we already, look, it's the exact same stinking numbers. There's my 16/3, there's my -4, there's my plus 5. This ends up also being 19/3. So, just to highlight this again, one more time here. What I have now, this is the big idea of accumulation. He puts all sorts of stars next to it because he knows how often it shows up. What I have now is equal to what I started with and what I've accumulated since I started. Okay, let's put it to work. So you're going to do a couple of things. Luckily, this says we can use our calc on A through C, so we're going to do some calculator stuff here. This is, I think he wants you to just get used to trying to set up this process. So I want to figure out what f of 3 is. My hint is that f prime equals this function and that f of 2 equals negative 2. So try to write up your own integral. F of 3 equals, and try to write up what you think that integral would look like. Going back to what we did before. So pause it, give it a try. Let's see how you did. This would be equal to f of 2 plus my accumulation since 2. So from 2 until when? Until 3. And because they've already defined f prime for us, we can just write f prime in there. Now, to figure this out, I would go to my calc. It says I can use my calculator. So I'm going to put in f of 2 we know is negative 2 plus, I'm going to integrate from 2 until 3. Now I do have to put the equation. Ooh, practice putting that in there. How do you handle that squared? Practice typing it in. Let's see how you do. Pause it and give it a try. Okay, so let's see how you did. So notice I put the 4 in first and then the parenthesis because I don't want to square the 4. So I've got my parenthesis around the 2x. I've got the parenthesis around the sign of 2x. That's the thing that needs to get squared. Then I'm going to finish my parenthesis around my integrand, and then I'm going to evaluate according to x. So I got f of 3 is equal to 7.762. Okay, I'm going to have you try the next two. I would recommend doing a second enter on your calc when you try to, oops, I turned it off. Second enter on your calc to change. You don't need to change any of this junk. You don't need to change that. You just need to change your boundaries, your upper and bottom, lower limits of your integral. So pause it, give those a try, and then come on back. Don't forget you got to write these up first. So you can't just write the answer. You have to actually write them out. So f of 5, that shows that you understand how this works. That starts at f of 2. And then I'm going to add on from 2 until 5 of f prime of x dx. So I get f of 5 is equal to 4.038. Now we're going to try for 2. Haven't used gray in a while. That's too close to green. I'm going to go with the red. F of negative 2 is equal to f of 2 plus the integral from, can we go from 2 until negative 2? Yeah, you can type it in, or if you want to flip it around, you got to make that a negative, but you can flip it around. Our calculator doesn't care. I don't care either, so I'm going to leave it as is. So I would get f of negative 2. I already did this. I got equal to, if you haven't, pause and try, 9.010. Okay, this last step then, make an integral equation for f of x. So this was the equation for f of negative 2, blah, blah, blah. This was the equation for f of 5, blah, blah, blah. This was the equation for f of 3. Look at what changed when we switched from 3 to 5 to negative 2 and try to generalize that into an equation. Pause it, give it a whirl. All right, let's see how you did. So my function is now f of x instead of a number. It always is going to start at f of 2. Now, if you wanted to throw negative 2 in there, you could, the number negative 2. But this shows that you know where it's coming from. Plus the integral from 2 until, well, what is this? This is whatever x is. F prime of x, squeeze in that dx. There we go.
We're a pre-response question. So of x. That's its name. You don't have to worry about parentheses. Typed in right there, your calculator recognizes. And then your template, you can almost just type it in once, keep it in y2, make sure you select y2, and then dx. All right, so I've already written it on my paper, my iPad. I hit enter. I let the calculator do all. No, that one gives you the position. By doing that, I'm going to go ahead. I wrote it on my iPad. I'm just going to recall it. A way to recall the previous line that's scrolling up and grabbing it. Yeah, just -2. Because if my upper limit of it, we changed our upper bound to 3. Some x value. Dealer's choice. What do you want to use? Schroeder, what do you want to use? What letter?
Oh, crap.
Ooh, my answers look like 5. Ah, nice. You know me. Yeah, F prime of SDS. College board typically uses T, of course, right? This time is another variable we use a lot. But you could choose. As long as it's something different than X, now there's no confusion of the independent variable. Rather than take F for that. All right, so on any free response question, you might have to do it specifically.